they use a special phrase called the if and only if. So in other words, if we combine these two conditional statements into one biconditional, okay, it would be a point is a midpoint, and then we say if and only if, and only if. Okay. All right. So if and only if it divides a segment into two congruent parts. And I just want to emphasize that um, in proving, you have to be very careful. If the definition says it divides it into two congruent parts, then you can't say they're equal. All right. So when you're writing your solution, for example, here in the example at the bottom left, M is the midpoint of AB. Okay. So we cannot say AM equals MB straight. We can't go to this second part over here. So take note that I had to state first that segment AM is congruent to segment MB, okay, before it said, oh, their measures are equal. Because if you remember, there's a difference between, I hope I can write with my writing slate. It did not work earlier. Hopefully it works now. Does the ink come out? Okay, so as I was saying, there's a difference between AM, okay, versus AM with the bar on top. So this is actually referring to the segment, while this is referring to the measure. Okay, so in the example, if M is the midpoint, then segment AM is congruent to segment MB. All right. We'll see how to use that in computations later on. Okay, so what is the difference between a midpoint and a bisector? So the prefix bi means two, right? So it's similar to a midpoint, but it doesn't have to be a point all the time. So if I may have a volunteer to read this for me, thank you in advance. Thank you. Thanks, Matthew. Thank you. So just like what Matthew read for us, it doesn't have to be a point all the time. It could be a segment, it could be a ray, or any subset of a line. It could also be a plane, as long as it contains the midpoint. So let's write again that definition that Matthew read for us in a conditional form. And again, feel free to resize your text boxes. Okay, so a point. What else? Ray. Oh, I'm sorry, I forgot my if. So if a point, ray, you can just put etc. But you know what I mean, right? I'm trying to like copy everything over there. Line, line segment, or plane intersects another segment at its midpoint, then it is called a bisector. All right. Let's see if I can make this bigger. I'm not sure if I can type though while 15% mode. All right, if a point, ray, or line segment intersects another segment at its midpoint, then it's called a bisector. Okay, so now let's write the converse. Oops, yeah, so that's my problem. I have to go back to the original so I can write in it. I'm going back. So going back here, maybe I could just make it bigger right here, zoom in. Okay. Hide floating controls, and then go right there. Okay. So now let's go to number 2 and write the converse. So if then let's just copy this one, it's faster. If a point or a plane, let's just stop right there, Control C, Control V. If a point, ray, line segment, or plane is a bisector, then it intersects another segment at its midpoint. Okay. Maybe I can make the font smaller, make it size 8. There you go. All right. Now for the biconditional statement, since it's a two-way conditional, it doesn't matter which you begin with. You could say a point is a bisector, or you can say a point ray line intersects at its midpoint, whichever you prefer. So I'm going to write it over here. I'm going to Control V again, the one that I wrote earlier. So I would say a point, ray, line segment, or plane is called a bisector if and only if, okay? And the shortcut for if and only if in geometry is IFF. There you go, IFF. hmm So every time you see me or you hear me use that, it's called if and only if. So if and only if it intersects another segment at its midpoint. All right. Okay, and you could just edit the other text boxes later on. So if you look at the difference between the image here and then the previous page, so point M here is the midpoint, and any subset of this line can be a bisector. Okay, so for example, segment DM could be a bisector. Um, you could write segment DM. The last time I also taught you how to use the latex in GeoGebra. So if you want to use that later on, that will be nice as well. I'm just going to write the whole words here so it will be so much faster. So segment DM, it could be line DC, okay? You could also say ray MC. So all those subsets are called bisectors because they contain the midpoint. Now, that doesn't stop the midpoint being the bisector as well. So a bisector is just more general, while midpoint is more specific. Okay. All right. And as you can see, it doesn't say anything about dividing it into two congruent parts. That's a big difference. So if you want to be able to write an equation, you don't use the definition of bisector, but you use the definition of a midpoint. Now, for now, you may be asking, okay, what is he saying? Why is it different? Okay, when we get to proving, you will realize that, oh, yeah, so whatever the definition is stating, then that's the conclusion we can make. So the only conclusion we can get from a bisector is that it contains the midpoint, okay, of the line segment. So in this figure, C is not the midpoint. Why? Because in the first place, it doesn't have that tick marks. Okay, it doesn't have those tick marks on both parts. I just want to emphasize that when you take your practice PSAT, I'm sure in geometry you saw something like figures are not drawn to scale. So even though this doesn't seem to be in the middle, if in the instruction it says C is the midpoint, then you're forced to use it as the midpoint, even if they're not equal or they don't look congruent. Okay? All right, so what we're going to do is use those two concepts. So in this example, we'll try to kind of break it down further. And I included more examples just so, well, hopefully we will be less confused as we were last time. All right, so in this example, it's about finding segment lengths. So this is a skateboard design, and VW, which is the shorter segment, bisects XY at that given point. And you can see that it has those little red marks over here. I hope it shows. I just took a screenshot of that. So what I would like you to do is in the chat box, I want you to give me the answer to xy. Find xy. So how are you going to do that? Xt is already given, and we know that a midpoint divides it into two congruent parts. So let me hear from you first. Like in the text box, go ahead and type whatever answer you think goes to that example. So type in your answer, even just the final answer will do, before we type it in the chat box. So what do you think is the measure of xy? Xy is the whole thing. Okay? In the example, it said that, let me see if I can write over it. In the example, it said xt is 39.9, and you're looking for the whole xy. Okay. So if you look at the figure, you can also type this in the text box if you want to. In the figure, you know that xy is composed of two shorter segments, which are xt and ty, right? I should not have placed the equal sign, but a plus symbol. Let me do it again. Okay, so xy is xt plus ty. So to find xy, okay, I'm guessing over here, because the markers don't show. Okay. So we're guessing that xy is equal to, your xt is 39.9 plus something else. But how long is ty? Anybody? Let me check the chat. All right. So, okay, a lot of you wrote 79.8, 79.8, 79.8. All right. Okay. The arrow show like your answer is the one on top, right? Okay, I'm guessing. Okay, awesome. So ty is the same length as xy? Are you sure? Or xt, Brian? Maybe you meant xt. Okay, yes, you guys are right. So that means for ty, it's also going to be 39.9. Okay, so how did you get that? Because by definition of a midpoint or bisector, right? We said it's a bisector here. So if it's a bisector, then that means T is the midpoint or the middle. Okay, you add it. Very good. Okay, thank you. So that means XY will be 79.8. So the answer here would be XY is equal to 79.8 centimeters. Okay, cool. All right. Let's look at another example. I'm going to clear the ink here though. Okay, here we go. I should write a text box. Okay, point M is the midpoint of VW. Am I too fast, or is my pace better than last time? Okay, so um, you're good. Okay, cool. Just let me know, because there were so many people confused last time. So point M is the midpoint, and find the length of VM. All right. Okay, so if M is the midpoint, then what do we know about these two? We know that VM and MV are congruent, right? So since VM and MW are congruent, okay, let me make that longer. And I'm going to run out of space, so I'm going to make the font smaller. Oh, I wish I could just write on the board. Okay, so here we go. Since VM and MW are congruent, then their measures are equal. All right. Okay, so if their measures are equal, we would say VM equals MW. And just like in algebra, by substitution, so VM has 4x minus 1, right? It shows right here. While MW is labeled by 3x plus 3. So equals 3x plus 3. If you find me too slow, you can, move on to the next slide. So Yeah. All right. So 4x minus 1 equals 3x plus 3. And then you got to do your, you know, your properties of equality to get the x by itself. So if you subtract 3x from 4x, you get x equals. And then now you have to add 1 to 3, so you'll get x equals 4. But you don't stop there. You just know that x is equal to 4. You're trying to find the entire length, not the entire length, but find the length of VM, which is this one. So what are you going to do with the 4? Oh, 30, Brian said. So that means VM is equal to 4 times the value of x, which is 4. Oh, I should write the whole thing because you might get confused. Okay, so VM is 4x minus 1. So if I substitute the value of x, which is 4, okay, and take away 1, then I will get 16 take away 1, which is 15. I hope I wrote down enough details for everybody to get. Oh, okay, you meant the whole thing, Brian. I'm so sorry. Yeah. So if you want to get the entire length, if 1 is 15, 1/2 is 15, and you double it, then it's going to be 30 for VW, right? Cool. Okay. All right. Okay, so we're going to move on to the next one. Um, let's see. Let me scroll this to the side. All right, so now let's try these. You like my Bitmoji over there? Okay, so now try these on your own. Let's go. In this figure, PM is 1.8. So you can label that using your text box and put 1.8. All right. Identify the segment bisector, then find PQ. Okay. Identify the segment bisector, then find PQ. Okay. So let's write a textbook so we can. So how will you answer the first question? Identify the segment bisector of PQ. So in other words, what is that line, ray, point that divides the segment PQ into two congruent parts? So what are the possible answers? Possible answers. Okay. I'm going to wait in the chat. So remember, a bisector could be anything or the midpoint itself. Okay, so the midpoint is M, right? So that's one possible answer. But what else contains, very good, yep, M, point M max, cool. If you're going to write a point though, make sure next time make it capital letters. Josiah, when you're writing line M, the M should be lowercase. But in this figure, the M is a big letter. So we can't name it like that. And it's not a line either because it doesn't connect all the way. It does not extend all the way. So it is only like from here, and then it has one-headed arrow. So what do you call that? What do you call like a subset of a line that only extends in one direction? The other possible answer is starts with R. R. Ray. Very good, Linnea. And how do you name your Ray? Very good, Jeremiah. What letter do I begin with? T or M? T? Remember, it starts from the beginning letter. So M. Very good, Jeremiah. So M, or capital, yeah, and then ends with T. That's cool. All right, that's for the first question. Now, find PQ. How do you find PQ? So PQ is a combination of PM plus MQ, right? By segment addition postulate. I'm trying to kind of, bring back those things we learned in the past in case you guys were confused. It's by the segment addition postulate because it's divided into two portions. Okay? And when we start proving anyway, that's how we're going to do. So PQ is 7.2. Okay, so let's see. So PQ is, PM is 1.8, right? And if M is the midpoint, what does that say about MQ? What should I substitute for MQ? Should I substitute the same amount? What do you think? Should I put 1.8 as well? What do you guys say? Yes, right? So I'm going to do 1.8 also. Okay, so would it be 7.2 or lower? 3.6. Very good, Rihanna. Okay, and Linnea. All right, so PQ will be equal to the sum of those two, so that will be 3.6. And the unit used is millimeters. Okay. Yes, Caitlin. Thank you so much. That's good. 36 millimeters. Cool. Now let's move to the other one. Okay. Point M is the midpoint of AB. Find the length of AB. So let me get a text box again for that one. All right. So again, if this is the midpoint, then you know that these two portions are congruent to each other. Okay. So another way to say it is segment AM is congruent to segment BM. There you go. So in equation form, AM is equal to BM. All right. From there, oh, Brian had a question. Isn't 1.8 the half point of P and M? Oh, no, honey. It means PM is the length already. So, so it doesn't mean that the coordinate of M is 1.8. No, it means the length. Okay, Rihanna said it's 22. All right, let's see if we can get Rihanna's answer. So AM is 3x minus 4, and BM is 2x plus 1. Okay, so combining like terms, if you subtract 2x from 3x, you get x. And then if you get 1, you add the 4, it will become 5. Okay, so Rihanna, would you like to explain how you got the 22? What did you do after? Put 5 in the x. Awesome. So if I add them together, I get 3 times 5 for x, take away 4, right? So that's going to be 15 minus 4 is 11. Good. And the other portion, we expect that to be 11 as well because this is the middle. So 2 times 5, add 1, that should be 11. So combining them according to Rihanna, AB is equal to 11 times 2, which is equal to 22. That's awesome. All right. Okay. Good job. All right. Tired, Sophia. I know. I feel you. Okay. But don't worry. We have a short week this week. All right. Okay. So are there any questions about the midpoint formula? Now I'm going to show you something in Delta Math just so, you know, um, when you see it in your homework, you won't get confused. Okay, so find the midpoint of points A, -8, -9. So where's -8, -9? -8 to the left and then 9 down. I can actually, I think, share this with you. Am I right? I'm not sure. Okay. See if we can open the same problem that I'm doing right now. Okay. If not, I'm so sorry, but we're just going to show it over here. And then the other point is 2 to the right 5 down. Okay. All right. So what is this problem asking you to do in Delta Math? It's going to ask you to draw a rectangle that uses this line segment as a diagonal. So it's another way of explaining how to find the midpoint, actually. Okay. So if you start from this point and drag that one all the way to right underneath the first point, and then extend upward, there you go. So pretty much you're drawing a rectangle that has this line segment as the um, diagonal. Okay. And the reason why we're doing this is because, you know, in the lesson we just did, we already know what's the measure of half of it, and usually it's just a horizontal line. But in the next lesson I'm going to show you, it's going to be a slanted line just like this. So if it's a diagonal line, like what does it mean to find the midpoint? Okay. So to find the midpoint of the diagonal line, it's pretty much the same as getting the middle portion of the base of the rectangle. So correct me if I'm wrong. I gotta count it. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the bottom portion is 10 units long, right? So I gotta find the middle one. So 1, 2, 3, 4, 5. There you go. And then vertically, I have to move 2 upward because the height of the rectangle is actually 4. Okay, now be careful because, okay, did I count 5 right? Yeah, and then go up. All right. So 1, 2, 3, 4, 5, and then 1, 2 up. So same thing here. 1, 2, 3, 4, 5, and then 2 up because the height of the rectangle is actually 4. So if the segment is diagonal, the midpoint is actually the combination of the middle portion of the base, right? And the midpoint of the height. So now let's find the coordinates here. If you're going to enter your answer, you have to put the number itself. So the x number here is -3, and the y number here is -7. And then you submit the answer. So I think there will be like 2 questions that you will um, turn in like this. Okay? So that's correct. Now, however, um, in some examples, it's going to say find the midpoint of the segment, but now without drawing the graph. So how are you going to do that? Okay, so before we do this problem, I'm going to show you the lesson needed to do that. Let's move on to slide 6. And this is where you can see, yep.
Wait, isn't that the same thing as like, I think it was like x1 minus x2? Is that the same thing or no? Like you do
Yes,
it without the
yes. However, you said minus. You have to say plus.
plus?
Okay,
Oh, okay.
yes. Because when you guys are finding the middle, it's the same way as getting the average. Okay? So you might want to write that in a text box. The midpoint is actually getting the average. Okay? I don't even know how to spell now. Okay, so average, I meant to make it longer. Okay. So average of x and y coordinates. The minus formula that Jeremiah spoke about, that's in the next slide, and that's a distance formula. Okay, so remember there's a difference between the two. Midpoint is you're just finding the middle portion. Distance formula is you're getting the total length. So right now, we're just looking at the midpoint. Okay, so this formula says, oh, just add the first numbers or the x coordinates together and then divide it by 2. And then add the y coordinates together and then divide it by 2. Okay, so let's see. if we can apply that formula to the first example here at the bottom. It says find the midpoint. So let's make a text box to do that. Okay. So to find the midpoint M, we're going to add the x coordinates first. So why do I begin with the x? Because a point always has the x numbers first, right? So I add 1 and then plus 4, which is 5, right? And then I have to divide it by 2. Okay, I can't show fractions like here, so I'm going to write 5. I'm going to 5 over 2, so that's going to be 2.5. Okay? Because I don't have like the fraction bar in the text box. So 2.5. And then if I do negative 3 plus 2, you get a negative answer, which is negative 1. Now you have to divide that. What's negative 1 divided by 2? Then you get negative 0.5. Did that make sense? Let me write it again. So I added, oh, where's my number coming up? I added the 1, oh my God. Okay, so I added the 1 plus 4 together and divided by 2, right? And then the other one, I added the negative 3 and the positive 2 together, and then I divided it by 2. So 1 plus 4 is 5. 5 divided by 2 is 2.5. While here, negative 3 plus 2 is negative 1. Negative 1 divided by 2 is negative 0.5. Does that make sense? Is it simple? Easy? Yes? Cool. Okay. So let me clear that ink and move on. Go to the page where you have to try over here. Just try this, where not the one at the bottom, but the one on top. Okay, here you go. So what do you think um, is the answer to this? So find the midpoint. So we're going to add, what's the partner of 1? The partner of 1 is 7. Then we're going to divide it by 2. Okay. Then get 2, which is the first y number. You add it to the second y number, which is 8. And then you divide it by 2. So M will be, okay, and I see answers in the chat already. 4, 5. Awesome. Okay. So 4, 5. All right. So in Delta Math, you're going to do the same thing. Here we go. Find the midpoint. So what do you think should I put? What should I put? What's NP? No problem? Okay, so what's the middle? Add them up. Okay, so 5.5. So, all right. Let's see if this accepts decibel. So 5.5 and 5.5. Submit answer. Click yes. There you go. Okay. All right, so 5.5, 5.5. Cool. All right, let's try another one. New problem. Try again. Answer. Three, comma, 6. Let's try, Johnny. Yay! Awesome. Okay. All right, so how are we doing so far? A little better than last time? Yay? Good? Okay. One last lesson for the day, and then we're going to continue next time. So finding an endpoint. Okay. So this time they give you the midpoint already. So the result when you divide by 2 is already given. One endpoint is 1, 4, but we don't know what the other coordinates are. Okay, so again, if you want to visualize that, you can graph it, right? You can plot, and you can use decimals to do that. However, not all the time you go into graph. So let's do it algebraically. So if you remember in the formula, I'm struggling with my writing pen over here. Okay, so if you remember in the formula, it's x1 plus x2 over 2, and then y1 plus y2 over 2 is equal to the midpoint, right? Okay, so the midpoint here is already given. The problem says, there you go, that's the midpoint. Okay. The problem said the midpoint is 2.1. So let me write that 2 over here. So 2 comma 1. And then there's only one pair given for the points, which is 1 and 4. So those ones can replace your x1 and y1, because that's one x coordinate and then another x coordinate. Chat, subtract, this is easy, cool. All right, yeah, so now you're working backwards, right? So what we're going to do is your x1 is 1. Oh my God. Okay, so your x1 is 1 and your x2 is missing. But when you divide by 2, you know that the answer to that must be 2, right? Because the midpoint that's given to us is 2. While for the y value, your y value, and Johnny said 3 negative 2. Okay, cool. Your y value is 4 plus the other y we're looking for, and then you divide by 2, we must get 1. Okay? All right. Yep, Johnny. So if you work backwards here now, you have to multiply 2 to the other 2 on the right side. So 2 times 2 is 4. But to get the x2 by itself, see how Johnny subtracted 1 from the 4 and he got 3 in the chat? Okay. So this one will be x2 is equal to 2 times 2 minus 1. And Johnny is right. X2 is equal to 3. And then now do the same thing to the other part. You'll get y2 equals, you have a 1 on the right, you cross multiply the 2 from the bottom, and then you subtract the 4. And see how Johnny got negative 2? So y2 is equal to 2 minus 4, which is negative 2. Okay, and those are the answers that we're looking for. Okay, I'm sorry, it was like all over the place now. I run out of space. Okay, so if you're looking for the endpoint, you have to work backwards. Okay? Yeah. You're right, honey. Okay. So that's an example on how to find the endpoint. Let's try another one at the bottom. I'm gonna clear the ink. Okay. Or I don't know if you need time to screenshot that or take a picture so you can paste it later. I'm gonna take it away in 3 seconds. Okay. And one last at the bottom before we go. So you're looking for the endpoint again. So you're looking for one of the points. Okay. So your first number here. Okay, so your first number here is 1, 1. That's your x1, and then the other one is for y1. So if you use the formula, x1 plus x2 divided by 2 is equal to, okay, Johnny said 37, is equal to the first number that they give you in the midpoint, which is 2. Okay, so your x1 is 1. Let's write 1 plus x2 divided by 2 is equal to 2. Okay, so if you multiply 2 times 2 is 4, and then you subtract the 1. Yep, Johnny, x2 is equal to 3. Okay. All right. And then for the other one, You got y1 plus y2 divided by 2. Or Johnny, you might want to like explain if you're using like how are you doing in your head, while I'm writing it. That would be nice one to hear. Okay. So 1 plus y2 divided by 2. Yes, Rihanna. Yeah, because you're going to multiply 2 times 4 is 8. Okay, so 2 times 4 is 8. And then you're going to subtract 1. Yeah, good job. So 7. Y2 is equal to 7. Okay. All right. Okay, so I do hope we did a better job than last time and I did not confuse you. Um, One thing that we will go over next time is the distance formula, which is in slide 7. Okay. Um, I can finish it now if you want me to. It's included in the homework, but if you don't want me to, then that's fine. I already went over time, so okay. But just to kind of give you a heads up, um, it's the same thing that we did today, but you're using a different formula. So you have two numbers, two endpoints, two sets of coordinates. Okay, and you're trying to find the distance between them. We could continue with this. Um, okay, Johnny said, I'm just looking at the midpoint. Good, and then we multiply it by 2. Awesome. And subtract the given coordinates. Yep, that's right. hmm So it's like order of operations. You undo the division, so you multiply by 2. And then you undo the adding, so you subtract by whatever coordinate is given. Cool. All right. Okay, and the last but not the least is the distance formula. You will also see this in the homework. So let me just give you a quick example. And this has been mentioned by Jeremiah already earlier. So to find the distance between them, instead of adding them, you're just going to subtract them. So let's say, for example, 1, which is the first number, and then 7 is its partner, right? You're going to match them up. That's the x numbers, that's the y numbers. So 1 minus 7, you have to square it, plus instead of minus. Then you go 2 minus 8 squared. Okay. And then you have to get the square root of that, all of that. All right. So what's 1 minus 7? 1 minus 7 is 6, right? 6 squared is 36. Plus 2 minus 8 is also 6. Oh, 0? Try again, honey. So 2 minus 8 is negative 6. But when you square the negative 6, Johnny, it's going to become positive. Does that make sense? Oh, okay. So then this will also become 36 because negative 6 times negative 6 is also 36. So that means the distance, oh, I forgot to write the square root, is actually 36 times 2. Do you see what I'm doing? Now, why do you think I'm doing it that way and not writing it as 72? Okay, I'm not writing it as 72 because we have to separate the perfect square number anyway, just like what we did in Algebra 1. So to find the answer, oops, what did I do? Okay, so to find the answer, what's the square root of 36? Oh, now this star is coming out when the period is done, huh? Okay, so the square root of 36 is 6, okay? But 2 does not have a radical sign, so the 2 must stay inside the symbol. Okay, so now I lost the star again. Okay, so 6 radical 2. Yep. Okay, so where did 6 come from again? It was the square root of 36. You're right, Dominic. Uh-huh. And then the 2 is not a perfect square, so it has to stay under the radical sign. Yes, Brian, you can also change it to decimal. However, in the Delta Math homework that I gave you, It's just accepting radicals. That's why I explain how to do it this way. All right. Okay. So let's look at some delta math examples of this one. So delta math. Back. Now I need the distance, not midpoint. Okay. Come on. Oh, it's froze again. Chat. Oh, there you go. Distance. Oh, I forgot. Sorry. Could you explain what a radical is again? I didn't hear you. Oh, um, a radical is, for example, this one. 36 is a perfect square because it's 6 times 6, right? So the square root of 36 went outside already, which is 6. But 2 is not a perfect square. Okay, so it has to stay under the radical sign. Just like how um, we simplified the examples we had in algebra 1. Okay, so I meant to go to delta math so I could show you some distance formula. Here we go. All right, so let's do this. Find the distance between 2 points in simplest radical form. So remember, you subtract. So 3 minus negative 6. Okay, you square. And then and then you subtract again instead of adding them. So negative 8 minus 4 squared. And after you get that, you get the whole square root. Okay, so be careful with this. You might want to write it out, because if you miss one negative sign, then that's going to be wrong. So 3 plus 6 is 9. Squared is 81. Okay. Negative 8 minus 4 is negative 12. Negative 12 squared is 144. Right? You have to get the square root of that. Okay, if we combine that, what do we get? 125. No, 225, sorry. There you go. All right. Oops, chat. So any perfect square. Yes, honey. Any perfect square has a square root and it can be taken out of the radical sign. Okay. Yes, Brian, it's 15 because 15 times 15 is okay. So let's type that in and see. Yes. Yay! And we got 15 as an answer. There you go. But it kind of shows you how to work it out as well. And there are some videos as well. Now, in case you didn't understand the distance formula, you know that this is just the same as getting the Pythagorean theorem. Because when you draw the endpoints, you can create a right triangle. And you see how I got the 9 over here? It's just the same as the 9 on the base. And how I got the 12 earlier, it's just for the height. So you could also do a squared plus b squared equals c squared, right? So a simpler way to think about the distance formula is you're just creating a triangle, from the endpoints of the segment. And you're doing the Pythagorean theorem to solve for the hypotenuse. All right. Okay, so I do hope that our pace is better than last time. I, you know, in I I intentionally planned on breaking those lessons down so we can have enough examples after each concept. So I hope I was successful at doing that today, so I don't confuse you the same way you guys were confused last time. Oops. Okay, do you guys have questions in particular? We're going to look at the two word problems next time for the distance problem. Nope.